Now, the last topic of the prehensile motion is in relation to Fitts law. Well, Fitts law was just aiming, but if we add the grasping component, will the Fitts law still apply to that prehensile movement? So can we predict the movement time of the prehensile motion with the Fitts law? The Bootsma et al. 1994 say yes. If we know how about object size and movement time? Movement amplitude, sorry. So this might indicate the difficulty, index of difficulty, and if that's index of difficulty, it has the linear relationship with movement time, and that is the Fitts law. What they found out from their study was actually it wasn't the size of the object, but actual width of the object. So it wasn't the size, but width of the object and movement amplitude. If they combine those two, they could actually predict the movement time. So what is the movement width? So if we have three different objects, well, these two are the same size. But if we were to grasp this object like this and grasp this object like this, oh, it's not needed, this one. And let's compare between grasping this and this. Two difference. One difference is the width is different. So width is the area of the contact. So the second object has larger area of contact than the first object. So even though they're the same size, it has greater width. And we can predict that even though we have, let's start here, we have the same amplitude of movement, so this versus this. This is actually faster because the width is larger than this one. So Bootsma, again, it wasn't the size that mattered, it was the width, which is the contact area. So this is the graph that they found the almost linear relationship between the index difficulty expressed as using amplitude and width of the object, and it shows linear relationship with movement time. So yes, the Fitts law applies when we apply width and amplitude accordingly to prehensile motion. Interestingly, Latash and Jarek did the unique study using the mug-cup. So they had different mug-cups. Well, I don't have that much mug-cup, but compare between two. And in their case, they had different level of liquid on the mug-cup. And in this case, they defined index of difficulty as the size of the mug-cup and the level of water. So they express as this one, water level. And combine those two to come up with index of difficulty. So for example, if the size, let's say this size is about 5, arbitrary size, and the level of water, this is about 2, the index of difficulty for this mug-cup is 5 divided by 2, it's about 2.5. And in comparison, for this case, it has a smaller size, so let's say it's 3, and the level of water is about the same, 2. So this cut the level of difficulty would be 3 divided by 2, which is 1.5. So again, what Latache and Jarek found was the relationship between the index of difficulty and movement time. And because it was not logarithmic, when we put the logarithm to the base of 2, this also showed linear relationship